Good evening. Welcome to the IEA Bioenergy Conference 2021. Today's session is in industrial synopsis and biorefineries in the circular economy. This is a very welcome from my side. My name is Michael Mandl. I have the pleasure to guide you through this session. And with me is also Johanna Mosberg. She's our co-moderator. Welcome to Johanna.
Thank you very much, Michael. Biorefineries is my favorite topic, so thank you very much for having me as a co-moderator.
I'm very pleased that you're with me to give me some support. Johanna, she is a vice acting president in RISE, in the Research Institute in Sweden, and she's really very much our expert in biorefinery. And together we're going to moderate this session tonight. Well, tonight, wherever you're joining in, it's going to be morning or afternoon. So this is a global event, and therefore we have mixed times. We have a session ahead with 4 speakers and very interesting topics. But before we go straight into maybe just a short introduction, what this session will be all about. We will try to have a very condensed presentation, and we would like to have maybe 2 questions after each presentation. And we keep the questions, we keep the powder dry, so to say, for the after panel discussion. Also, we would like to be getting some feedback about you, about your biorefinery background. And for that, we would like to launch our first poll to interact with you. So Johanna, maybe you can introduce us to the poll.
Yes, hopefully now you will have the poll just coming up to your faces now in Zoom. And we would like to know, for the first question is, which sector you are working in. So we want to know who you are. Are you from the politics, from the industry, or are you from the R&D side? And then we also would like to know, like, how deeply have you been involved in biorefinery? So far, have you like 50 years of experience? I think I'm a biorefinery expert, but I have not been around that long. Or do you feel quite new to the field? So please fill in what suits you and then submit so we can get a feeling, because we will introduce the presenters, but we would like to know all of you as well. And I think that if we all fill in, we will soon be able to have a result. But I noted, Michael, we didn't get a presentation of you. Who are you?
Oh, well, yeah, I might just introduce myself. I'm also a biorefinery person, active in R&D for about 20 years. My special field is really in integrating processes. My favorite topic is in green biorefinery to valorize grass and other fresh feedstocks. But anyhow, biorefinery is a very big field, and we're going to get into it today on a wider angle. So could we get the results of our first poll just to see about a little bit about the audience? Okay.
That you can actually see, it was, now we say only 42% from university and education. I thought that we would be maybe over 50, and we have 16% from the industry.
That's great.
Nice. No one from the politics side, unfortunately.
Okay, well, but the public sector is there, that's fine. And also the media and communications are there. And as far as the skills are concerned, that's quite interesting. Yeah, we have quite experienced people in our audience. Welcome. So we are, I think we'll have the discussion on a very high level. That is great. Well, let's go straight into it. And Johanna, could you please introduce us to our first presenter?
Yes, happily. Then I would like to invite Mats Eklund to the Zoom room. So while I introduce you, you can turn on your camera. Hi, Mats. And Mats is the director of the Transdisciplinary Biogas Research Center at Linköping University. He also is a professor in environmental technology and management and the scientific leader of Biogas Research Center. And he has a PhD from the Multidisciplinary Research School of Water and Environmental Studies, and he's been a professor in the technical faculty since 2007. so to say, not in Swedish. And also a fun fact is that when I did my master's, Mats was also one of the teachers. So we can say that my biorefinery career started quite early with Mats as a teacher. So that's some fun fact that goes way back. But with this, Mats, I invite you to the room and please share your presentation, and we look forward to hear what you have to tell us about the industrial symbiosis and biorefineries.
Thank you very much, Johanna.
I think you will have to press that one. Now it looks perfect.
Yeah, so the title of my presentation here today is Green Innovations Through Industrial Symbiosis. And if some of you say you would define yourselves as biorefinery people, I'm probably more of an industrial symbiosis person. And if you want to have another term for what industrial symbiosis could be, it could also be coined like as the science of the leftovers, which I think is also quite a useful term. My background is, for quite some time, I've been involved in biofuel industry, studying our local initiatives in ethanol, biodiesel, and biogas, biomethane for transport. And what we learned many years ago was that this industry was not static. They were trying to raise the value of underutilized resources. They were trying to diversify their inputs, and a lot of things was actually happening all the time. So what I will represent here today and introduce in my presentation would maybe be some kind of role for academy to be uncovering bottom-up initiatives, where something which actually starts as a biofuel initiative turns more and more into a biorefinery or sort of enables such a development. And industrial symbiosis is quite a lot about social processes as well. So that's a bit of my background. I always like to start with this image. It's from 1928. It's a place in the Lake Vänern, which is called Skoghallsverken. And what they did here in 1928 was that they put a tree in one end, and they put a lot of different products out the other end. A very diversified activity. So I would say that this industry was input oriented. It was to make as much product as from your raw material as you had. It was diversified and integrated. And if they would have had the term biorefinery, they would probably have called it that at that time. But what we should remember is that about since 100 years or so then, we've actually told everyone to do something very different. What you should do instead is that you should specialize. You should be a specialist in operating one special paper machine, for instance, for the global market, and you should grow your scale. And that's that's one of the reasons why we also have so many different kind of environmental related problems. But we also have a lot of good things coming out of this core business focus. It has served large parts of humanity very well. In large parts of the world, we could actually just step outside. We could buy anything we want at any time of the year at very, very competitive prices, which is quite amazing. The backside of that coin is that when everyone is doing their core business, we create more and more resource and pollution problems. If we only grow wheat for 50 years in one plot, for instance, like we have some areas in Sweden, or if we put 50,000 cows in one feedlot, we will have a lot of problems there. If 50% of all the beef tomatoes used in entire Europe comes from one greenhouse in the Netherlands, using subsidized natural gas for CO2 and for heating, or we have large-scale fish farms, for instance. That is making the systems, these specialized systems, to create more and more resource and pollution problems, because these sectors and supply chains, they are disconnected from each other, and they mainly rely on primary inputs. just one amazing example from the Netherlands. Maybe would be other people who can comment on this later, but I think it's amazing that a country which actually have no resources, almost any, except its fantastic people, are the second largest food producer in the world. And they really have gone for the core business idea. They put a lot of pigs in one part of the country, their horticultural sector in another part of the country, and the arable farming in a third region. And in these different activities, of course, generate different kinds of pollution and resource-related problems. But of course, they can also be linked. There are organizations looking into how can we reconnect these sectors to each other. I mean, what is a manure excess problem, generating a lot of different problems? Of course, that manure should pass through a digester where the nutrients can be benefiting horticulture or arable farming. Heat, CO2 could also be used. And through the biogas technology, we could also generate some energy as well in such a system. So there is a big need to reconnect parts of systems, definitely. I'll just give you one example from a study we made many years ago when we mapped tomato production in Sweden. And 1 kilo of tomatoes typically generated 1 kilo of CO2 emissions in their entire life cycle. And the main source was the energy needed for heating the greenhouses. But of course, there were also transports and other things. But we found a very good example. Sweden's second largest producer, Elleholm's tomatoes, they got their heat from a pulp mill, and the CO2 came as a byproduct from a liquor production. And when we put these data in the LCA, they were actually 20 times better than the average tomato. So it's quite amazing to think you step into a store, you could buy those tomatoes or those tomatoes, and they're comparable in all regards, but one of them is 20 times better from a climate perspective, because it is using low-grade waste heat from a pulp mill that used to go directly into the Baltic Sea, but now takes its way through the tomato growing. I've also come into working a lot with biogas solutions, and this would be one illustration where you sort of in some way can see that what they are doing is that they are connecting different sectors in society. Of course, they are dealing with different kind of wastes from different industries. You have the digestion, you have the upgrading, and in the Nordic model, it would typically go for transport fuel, and we have a nutrient recovery going back to the arable lands. So by this, it's inherently symbiotic and connects different sectors. Some examples from uncovering activities that we are doing. One place called Lidköping in the western part of Sweden, where there is a wheat growing district, where they're producing many different things from the wheat. Alcohol first, sold under the brand Svedka vodka in North America, bringing in a lot of income. They're also separating gluten, starch, glucose syrup, and there is some of the wheat is turned into animal feed, and the wet waste goes into a biogas plant. And together with residues from other parts of the regional industries. And here they were first in Sweden with producing liquefied biogas, Bioenergy. But also worth noting is the fact that the biofertilizer goes back to the fields reduce the need of commercial fertilizers by about 30%. So of course, some of the nutrients will be lost in the other products produced in the system, but at least some recovery of the nutrients occur in that sense. And this is quite interesting. When we map flows in Sweden of different cities, people that we meet will never have seen this before. But one thing that is quite common is that you have a heat and power plant in a city, and it operates on waste or bioenergy from the city and imported. It produces electricity and district heating, but also in some areas steam. And in this case, for the biorefinery, Lantmännenreppe, so they get a better process energy than if they were solving this on their own. So the steam is mainly giving the energy they need. Some of the wet residues go for biogas production, which in turn also generates the fertilizer that goes back to the farmers. Some other fractions go back to fodder production. So these are systems that have evolved without a master plan, without anyone planning them or working on implementing them, but they are there. We can uncover them, we can learn about them, we can understand how they evolve over time. And the value creation that that industrial symbiosis can bring is of course to create a situation where we want to strengthen industrial competitiveness. We have some industries in Sweden who actually says that we are the only one in business in Europe. And we are that because we, on top of what we are normally doing, sulfuric acid or carbons, we also have a heat collaboration with the city. So we sell excess heat, and that's why we still exist, basically. And at the same time, when you actually link these companies with each other, what you do is that you work with innovation. You increase the value of underutilized resources, and sometimes you improve the coordination of the industrial areas. And at the same time, it's worth mentioning that most of industrial symbiosis literature is about systems that are fossil-based. So we always say that our role in Sweden is to stress the dimension of the bio-based and circular economy in this regard. Another example from a neighboring city where close to where I live is the Händelö Eco-Industrial Park in Norrköping, which is out on that small island outside city of Norrköping, which actually uses waste, bioenergy, and wheat. And there we have Sweden's only large-scale ethanol production. And it used to be called like the ethanol plant. Today, it is not. And it's also a much more complex system that has evolved, generating fodder, fertilizer, biofuel, both biomethane and ethanol, electricity, district heating, district cooling, and carbonic acid as well. So looking into the biorefinery there is a very interesting as it is. I mean, they are producing, you see the black arrows are the existing structures where mainly the wheat generates the animal feed, the ethanol, and CO2, which are all products. They are right now building a gluten factory, investing quite a lot in that. They've also started using more and more byproducts as feedstock. And a lot of different innovation is going on with also food applications, bioplastics, etc. So we see that these biofuel-related actors have not generated static production systems. They have kept on evolving in a direction towards biorefineries all the time. My last example is from the west coast of Sweden, where we have the most of the Swedish fish processing industry. There are some very big Norwegian companies there, and there they are processing a lot of fish that is being caught and turned into food. But also some new things have just evolved. Land-based fish farming is there and some other activities. And until a couple of years ago, a lot of the fish guts and the wastes that was generated here was transported away. And then an intermediate company called Rena Hav said, we want to build a water treatment and biogas plant for all fish industry here, because then we can keep all that waste here. We can generate energy and other things, but we can also more and more work with development of fodder or proteins and everything that is really useful that we will find in that waste. So now that plant is built and operating, and they see it as an enabler, basically an enabler for the biorefinery development. And here you can see the three large fish industries, Maranur, Lerøy, and Orkla. They are today sending their wastewater and different bio-waste to an intermediary company that are treating the wastewater, producing biogas, and become a bit of an energy hub of the system. Today, the land-based fish farm is building they are building it right now, as well as the Swedish algae factory. So we see how a system evolves, and in this case also very interesting how the municipality created what they call Sotenas Symbioscentrum, which is a way of creating an arena where more of these actors meet, where they can start on joint projects, find external funding, etc., for different kind of test beds and other things. And when they are communicating about this, they are also getting more and more known. So people call from somewhere in the world, say, oh, we want the blood from the salmon. We want to establish there because we want to produce this and that product, etc. So I hope my presentation has just given you sort of some kind of idea that there are inherent forces in the sense of making better business and utilizing resources better that come from the industrial symbiosis field and may make bioenergy or other kind of industries develop into more or less more advanced biorefineries. Thank you very much for listening.
Thank you very much, Mats. I noticed when you talk about this, it's very interesting that you mention all these examples of industrial symbiosis, and they are bio-based, so they go for biorefineries, of course, if you take the broader system perspective. And I just have a question, because when you speak about the benefits of the industrial symbiosis, you mentioned that you can value underutilized resources or flows that have no or a low value, and you can raise the value of them and create a more better economy from a systems perspective. But since those benefits are usually not within one single actor, the symbiosis is a collaboration, who should take responsibility to initiate symbiosis or manage, so to say, the symbiosis, because it looks rather complex.
Yeah, I think that in these examples, you could say that sometimes there are some big companies that want just keep on developing new things, for instance, close to what they're already doing, for instance, applications in the food industry or something. That is one thing. In the Sotenas case, and sometimes we see more new companies, intermediary companies, that see the role that there is a need for someone who takes over and taking over the leftovers, because there is no one at Maranur or the fish processing industries that have it as in their core business. So no one else will do it unless new actors step into the scene and take over some of these things. So it could look a bit different.
Yeah, so more or less like symbiosis brokers or something like that.
Yeah, sometimes they are definitely needed.
Well, I might just jump in here. I would really like to encourage our audience to raise questions in the Q&A part of our call. That's the place where you can drop them. We will be watching them and raise the questions. And all the topics we'll be going to get there, we will summarize and we will also discuss them later in our panel discussion. So please use the Q&A section for raising questions. What interests me really, Mats, because you said this all was sort of created without a master plan, which seems to be completely astonishing. Do you think that if you had a master plan in forehand, this would go better, improve, go faster, or have a optimized output?
I think that in a country like Sweden, and I think large parts of Europe, a master plan would never work. I think that would never happen. That's how I see it. There are other parts of the world where a lot of the industrial development actually takes place as master plans, but we are not one of them. Here, I think we would have to rely more on, I think, partners finding each other, really, more bottom up, and maybe enabling sort of that to happen. So when people who are looking for salmon blood get in touch with Sotenes and say, okay, we want to buy all the blood you have, and we want to have our factory in your place, for instance.
There's an interesting question just popping up, and that's maybe you have some experience about that. What happens, if one of our core partner in the symbiosis system is facing economic problems, and then gets bankrupt or stops business? What can happen then?
Yeah, I think a lot of people think that that is really the big problem. I think it's a small problem because industrial symbiosis is about strengthening competitiveness. It's about making your business better. Otherwise, you shouldn't get involved in those collaborations. And I think there are no companies that are not relying on their entire ecosystem of everything they are a part of. I mean, customers or world markets or whatever. So I would say that being part of a strong network, I think Kalundborg, the Danish example, has really shown a capacity to be a resilient place where they have actually evolved and changed and developed their industry that was mainly fossil, which today is to a large extent renewable, etc. So I don't think, you're always like, it's difficult to rely on anyone, but there is no other way. Really, there is always a risk of going bankrupt.
Okay, thank you again, Mats. We will come back to this topic later in the panel discussion. Johan and I, when we discussed about the moderation, we thought, okay, we would somehow give a little gift also to our speakers. And it's very difficult to do that in that sort of conference meeting. But, well, I brought some product for you, which I want to show you here in the camera. It's black, and then I think that is something I would like to give to you as a Biorefinery sort of award or gadget. It's biochar. It's actually produced in a small pyrolysis unit out of husks, and I think you know exactly what to do with it. And it comes also with some very nice labeling, saying something to think about, and this will be sent over to you. Thanks again.
Thank you.
Okay, we're going ahead with our topics, and I see already we have the second poll being executed. So the second poll was about products. We wanted to know your opinion about what product you think going to be produced by biorefineries in the next 10 years. And we see here that's quite an interesting share. Wow.
It's very, very well distributed between the ones. It's
yes.
a bit of a winner in the second generation biofuels. Then
that was expected, though.
Yeah. But it's also nice to see that we believe in biorefinery produced hydrogen, because I assume that we were still at large scale biorefineries. So that is an interesting one, that the hydrogen economy is not only based on the electricity, but also as a product from biorefineries and interpretation.
Yeah. I think our audience is strongly convinced that biorefineries can produce a wide range of products. That's I think one conclusion we can make from first poll. And the second question, okay, was about feedstocks. You know, which type of feedstocks you're going to think is going to be used. And here, well, the lignocellulosic fractions and the agricultural residues, they are the top scoring. And also with the organic waste from household, that's also very interesting.
Yeah,
Anyhow,
and I'd like to highlight, we can see also the CO2, because we have 30% that also highlighted CO2 as a good feedstock or a resource for a full carbon utilization of the bio-based carbon. And that's also a nice take of a full carbon utilization.
Okay, great. Thanks for your interaction and your feedback. This will bring us straight away to our next speaker. It's a pleasure for me to introduce Bert Anverlink to you. He's a senior scientist in biomass change. He's based in Wageningen Food and Biobased Research in the Netherlands. And despite being a senior scientist, he has also been involved in a lot of European projects in framework programs and different kind of funding. But most important, Bert is also a task leader of the IEA Bioenergy Task42 Biorefinery in a circular economy. So welcome, Bert. The floor is yours, and you can also start maybe with an interpretation and your opinion about our poll.
Yeah, thank you. I'll start sharing my screen. Share. And then putting it on full screen. Yes, can you see it?
This works very well.
Okay, great. Well, thanks for the introduction. And when I saw the results, I actually thought, well, I can skip my presentation because at the end we've got some results from looking at the Biorefinery database. And well, this is not completely the same, of course, but it does resemble the answers of the audience. So, but let's have a look at my presentation, and then you can conclude if you agree. Because today I would like to show you a bit about the status of biorefineries in the circular economy. I would like to start with the Task42 definition of biorefining, and that's actually quite simple. It is sustainable processing of biomass into a portfolio, so more than one, of marketable bio-based products and bioenergy. And the products could be food and feed ingredients, chemicals, materials, minerals, etc. And the energy could be fuels, power, and heat. In the picture, you see that we first of all need, of course, sustainable biomass supply, and then a sustainable pretreatment technology is used in a biorefinery to extract and separate various platforms like proteins, sugars, lignin, oils, and fibers. And these then can be used to deliver different marketable products. A bit about the task. Task42 was started already in 2007. Michael was there already. And we are now in our 5th triennium. And you can see the current member countries here that are Austria, Australia, Denmark, Germany, Ireland, Italy, the Netherlands, and Sweden. And in the next triennium, the US and Turkey will be joining. Task42 really believes that biorefining is one of the key enabling strategies of the circular economy, closing loops of raw materials, minerals, water, and carbon. And it's the optimal strategy for large-scale sustainable use of biomass in the bioeconomy. The picture shows that biorefineries are, in our opinion, in the center of the circular economy, converting renewable resources in a wide array of products and with various recycling loops. And then this way, biorefining will result in a cost-competitive co-production of food, ingredients, bio-based products, and bioenergy, combined with optimal socio-economic and environmental impacts, like, for example, reduced greenhouse gas emission, efficient use of resources, etc. Sorry, I have to remove a poll now for a moment. Yeah. Oops. But this blocks my, oh no, sorry. Yeah. Technical reports. Sorry, I think I want to, no. Sorry, because oh yeah, this is one. We are delivering our information often in reports on the status of biorefineries, and you see 4 examples of reports that we recently produced. The biobased chemicals report gives you an overview of a wide range of biobased chemicals that can be produced in biorefineries. The technical, economic, and environmental assessment of biorefinery concepts reports describes our TE methodology, and I'll show you 2 more slides about that later on. Then we had a report on lignin as an alternative for non-renewable coal consumption. And finally, very recently, there was this report on sustainable lignin valorization, and that was published last month, and there was a special webinar, and you can find these presentations in the IEA Bioenergy website. Okay, then one slide about the TE assessment methodology. The objective of this methodology is to underpin the sustainability claim of integrated biorefineries. And this is done by a quantitative environmental and economic assessment approach. Generic initial models of biorefineries are used and then iteratively improved in the assessments. In the figure, you can see that the methodology consists of a qualitative part A, a quantitative part B, characterization of the biorefinery pathway, and then a template part C to collect the primary data. We actually encourage stakeholders to participate in this assessment of biorefinery technologies with our TE methodology. So if you have a specific biorefinery pathway that you want to have assessed, then please contact us. And finally, with this TE methodology, we want to provide an open access approach. With the methodology, we have already produced many fact sheets in the past, and here you can see 4 of the recent fact sheets that we have produced. And on the right-hand side, you can see how this looks like for the fact sheet of the 2-platform biorefinery C5, C6 sugars and lignin, using corn straw for the production of bioethanol and electricity and heat, so the green one. At the moment, we are still working on, together with Task43 gasification, on several pathways that are based on gasification. So more fact sheets are there to come on our website soon. And then finally, some other activities of our task are mentioned here. So the TE methodology has also been described in our annual IEA Bioenergy report. We have country slide decks that provide local information about the members of Task42, the member countries. Recently, we also had a cooperation with the Biorefinery Outlook project. That project was focusing on chemical and material-driven biorefineries. And we have a cooperation with the IETS Task 11 on industry-based biorefineries. And Marzouk Benali and Paul Stewart will explain about that task later in the 4th presentation today. And finally, we have a dedicated website where you can find all the information. So now about the second part of my presentation is about the Global Biorefinery Status Report. That's another major deliverable that is due in this triennium. However, the work is still going on at this moment, and there will be a draft report in December, but that then needs to be finalized. So the final version of that report will be there by the end of March. But now I will try to present already some preliminary results in the next slides. But these results might still change, of course, given the final analysis. So please wait for the publication of the final report in March before you start citing this report, if at all, of course. This slide shows you the draft content of this report. And today I will show you one of the slides, only one slide on understanding biorefineries. That's the chapter 2 of the report. And then some slides on the first results of the analysis of the deployment status of biorefineries. That's chapter 4. And the next presentation tonight will be by Franziska Hesser about barriers and incentives for the market diffusion of biorefineries in a circular economy. And that, of course, closely relates to this chapter 5, but I will not discuss that then today. The slide about understanding biorefineries. This has 3 parts. On the left side, you can see the original Task42 classification system. And that was then already based on 4 categories: feedstock, conversion process, platform, and product. And we needed such a classification to understand the different types of biorefineries that exist. Then this original Task42 classification was recently updated in the Biorefinery Outlook to 2030 project, which I already mentioned just before. In the table in the middle, you can see all the updated items within these 4 main categories that I mentioned. And these lists of items are really much more detailed than in the original classification, especially for the chemicals and materials part on the right-hand side. And then on the far right-hand side, you can see an example of one of the 11 biorefinery pathways that were described in the Biorefinery Outlook project. And this example is a pathway E, the 3 platforms, C5 sugars, C6 sugars, and lignin, biorefinery pathway using lignocellulosic biomass. And so that's actually a small part. You could see it as a small part of the figure on the left. Then coming to the analysis of the deployment status. For this, we use the Task42 Biorefinery Atlas portal, which gives an overview of the worldwide biorefinery deployment status. On the right-hand side, you can see the portal homepage with all the biorefineries plotted on a map, all the biorefineries in our database. You can zoom in on this map to a certain region, select some features from the column on the left. That's a dark bar on the left side. And in that column, you can, for example, choose if you want to see the feedstock, the production capacity, TRL, refining technology, or products. And you can also download self-selected data subsets. The picture below that map shows you all the details of one specific biorefinery record that was chosen on the map. And in this case, it's the Mater biopolymer biorefinery plant of Novamont in Italy that is based on vegetable oil. Unfortunately, the Biorefinery Outlook database has not yet been included in the portal because we are still waiting for permission from GRC and the EC to include those records, but we hope we can add them as well. But today the portal is actually officially launched, so please start exploring the portal using the link that I mentioned here. And I must mention that these biorefinery data will be updated continuously in the next triennium. So if you have any extra data, please provide them to us and then we can change them in the database. This slide might be a bit complex, but it describes the data that were used for our analysis and for the slides I show you later on. In total, we found 1,312 operational biorefineries in our analysis, and they were taken from 2 databases, from, let's say, our own Task42 portal and from the Biorefinery Outlook database. The data source used in the Task42 portal were very diverse, but they had more focus on energy-driven biorefineries. The Biorefineries Outlook database that was built by a Biomass Technology Group, BTG, in the Netherlands, in the Biorefinery Outlook project. that had more focus on chemicals and material-driven biorefineries. And I must also mention that in the analysis, we excluded all the biorefineries from the portal that were idle, cancelled, stopped, or shut down. But you can find them in the portal if you want to have a look at them. Okay, then going into some slides on results of the analysis, preliminary results of the analysis. So as mentioned, the total number was 1,312, excluding the cancelled biorefineries. And there was a large number of biorefineries found in the US, 637. But they have, I must mention, they have been excluded in the figures on the right-hand side, because then it would be a bit, the bar charts would be distorted a bit too much. If you look at countries with a large number, more than 40 biorefineries, then you're looking at the US, France, Germany, the Netherlands, China, Finland, and Sweden. Somewhere between 20 and 40 biorefineries were found in Austria, Belgium, Canada, and Spain. Okay, and then now I will show you the analysis of the three categories of the biorefinery classification. Three of the four categories: feedstocks, conversion process, and products. And then first, the biorefinery feedstocks. We could see that the main feedstock is a primary biomass, although, or however, secondary biomass is also an important one, but smaller, much smaller than the primary biomass. The primary biomass feedstocks, if we go into detail, the main ones are starch crops and oil crops. But sugar crops, lignocellulosic biomass from croplands and grasslands, and lignocellulosic biomass from forestry are also important primary biomass feedstocks. The main secondary biomass feedstock here is other organic residues, and followed by residues from agriculture and residues from forestry. Here you can see the representation of in the portal of these biorefineries based on main feedstock type used. You can see that the primary biomass-based biorefineries, the blue ones, dominate the map, although there are also many secondary biomass-based biorefineries, the purple ones. Please keep in mind that these 397 biorefineries of the Biorefinery Outlook database have not yet been included in this picture on the portal. Then going to the biorefinery conversion process. Unfortunately, there was a large number of blanks, and that's why we excluded them from the pictures on the right-hand side, again, to avoid distortion. These need to be further analyzed, especially for the US. But we can see that biochemical conversion is mostly used in biorefineries, and within that category, fermentation really sticks out. Chemical conversion is second in line, with catalytic conversion, esterification, and hydrogenation as specific technologies. Finally, mechanical and thermochemical conversion is often used, and that uses extraction, separation, gasification, and pyrolysis as specific technologies. And here you can again see that on the map where these biorefineries are located. And as mentioned, for the large number of blank dots in the US, we can probably assume esterification for the biodiesel plant and the fermentation for the bioethanol producing biorefineries. However, this still needs to be confirmed with our US representative, so I cannot be sure. We cannot be sure yet, but that's probable. And I must mention, fortunately, we can update the attributes in the database very quickly and easily, and then they can be shown on the portal. So that's the advantage of using the database in combination with the portal. Okay, then the final category of the classification of biorefineries was products. And we can see from the analysis that energy is still really the largest product group, and especially then fuels. Chemicals is, although produced in a much smaller number of biorefineries, are also an important product group. And building blocks are the largest type, followed by pharmaceuticals and nutraceuticals. Materials is the smallest group that still matters, and polymers and fibers are then the main types. And here you can see the representation in the portal again, and now the green color of energy really dominates the map. So I would like to conclude with some key points from this presentation now, which is a description of the status of biorefineries in circular economy can be found in various reports of Task42, including this new upcoming global biorefinery status report that will be ready in March. The open source TE assessment methodology of Task42 can be applied to analyze specific biorefinery pathways and to produce biorefinery fact sheets. So if you have any suggestions, please let us know. The newly developed Task42 Biorefinery Atlas portal is now available as of today for specific query stakeholders. And if you need any assistance or have specific questions, please let us know. And finally, we think that close cooperation is really needed with all types of stakeholders to generate more knowledge to further increase biorefinery deployment. So please contact us if you have any suggestions or new information on biorefineries. So thank you for your attention, and I would like to especially thank Sebastiano and Nicola for developing the GIS, Patrick Reumerman from BHG for making the database of Biorefinery Outlook available for our analysis, and Johannes, who is the contact person in Task42 for the TE methodology. So thank you for your attention.
Thank you, Bert. Just a question, a simple question. If I was an industry and would like to get my biorefinery included in the map, how would that work?
That would be, then you, the best way is to send us an email, and then we can refer you to probably to Johannes. And the way such a, say, assessment is made is that we have this, what I said in number C of the methodologies, we have sort of a form that you can fill in. And based on that, we can make the assessment, and we can help you, of course, with filling in this form and interpreting the type of data that we need and things like that. Does that answer your question?
Oh, well, I meant, you know, when a new setup or production site is going to be included in the mapping in the portal.
Oh, yeah.
How does that work? That basically it get displaced on that portal.
Yeah, that okay. There's two ways. At this moment, the way is to send us an email with the details of your installation. I thought you were talking about TE assessment, indeed. But for the portal, send us the information. But in the next triennium, we are working on a methodology that users can easily adapt their own facility or other facilities where they have knowledge of, and then do it themselves. But that approach still needs to be developed in our next triennium plan.
Thank you, Bert. We also had another question saying that it was a very good overview of the biorefineries, but a question if you also include the product-driven refineries such as sugar industries and pulp and paper industries. Is that included in the database?
Not as such. I mean, not in general, but if such an industry is working on a specific new biorefinery concept, then they are included. I must mention, if you go to our website, you can see, I don't know if it's on there yet, but there are other databases, for example, the GRC database that I mentioned. They have a broader view, and they also include traditional food, paper, etc. industry. So everything that is bio-based, let's say. And in this database and portal, we focus on specific biorefinery locations.
Thank you for that.
Given the very general definition, there is always a gray area, of course, of what to include and not to include.
Thank you.
Okay, I need to be the timekeeper also. I think we're going to step ahead. Also, we thought about a biorefinery award for you, Bert. And as I know, you always like a decent cup of coffee. So what I prepared for you here is directly from the kitchen are the leftovers from coffee making, basically. That means the spent grains. And so I put them in a recycled glass container, and you get also this special labeling on it, and we will provide it to you, send it to you. And what we really need to think about is, you know, when products or goods or service are included in our everyday practices in life, we need to think about the residues and how we're going to manage this in a circular way. So do you already have an idea how to valorize the spent grains, the spent coffee?
Going to send it straight to our labs to analyze what we can do with it. Thank you.
Okay. Well, maybe one hint, making coffee is a water extract, and coffee still contains some lipids and some oils. So if you use a solvent, a biosolvent, hopefully, then you can extract the lipids and start making products out of it, for instance.
Okay, thanks.
Okay, so we're moving forward. Johanna, could you maybe introduce us to the poll, to the next poll item?
Yes, we have a poll and we also have the results, but I think you would just like to know the poll questions, or would you also like the results, because they are coming up quite quickly.
So we have a very motivated audience. That's great.
Because I think that we would like to keep the results actually hanging for a bit and discuss them after Francesca's presentation.
Yeah, that's a good idea. Okay, so I use this opportunity to introduce Franziska Hesser to you. She's a colleague of mine here in Austria. She's a team leader in the market analysis and innovation research team. She works for Wood-K+, which is an Austrian competence center for wood and lignocellulosic materials. She is very linked to LCA, so making environmental analytics, and also she's doing market research and how can we actually push innovations and technologies towards the market. And she will be presenting to us a presentation on barriers in the field of biorefinery. I'm really looking forward. Franziska, the floor is yours.
Thank you, Michael. Okay, do you see the correct presentation?
It looks great, Francesca.
Yeah.
Okay, so I'll go on. So thank you for the introduction. Yeah, as Michael said, I'm part of the Austrian Task42 team, and one of our tasks was to dig deeper on market diffusion of biorefineries. From my work at Wood-K+, which is a biomaterials and processing R&D organization, and from my participation in Task42 activities, I have very much experienced a technology-driven view on biorefineries and their markets. So let's start from that point. I guess you are all familiar to this illustration of the so-called innovation funnel. It basically tells us that we need a lot of ideas to get one out on the market. So it's about 1 to 2% only, which have some kind of success. So not necessarily the big market boomers. So from idea to market, different research and development activities describe the innovation process, and we can formally describe that or even measure that, assess that with the technology readiness levels. I will use my pointer. Okay, right, here we are with the technology readiness levels. So starting with low technological maturity, our R&D efforts contribute to increasing the TRL, the maturity towards market introduction. And that new technology works in the lab or on pilot or demo scale does not necessarily mean that it also works on the market. So this is because innovation is not purely about solving technical problems. So let me quote Nuha here. So quote, technology as such cannot guarantee the success of an innovation if other aspects such as environmental, political, legislative, economic, social, networking and institutional factors are not accepted by the stakeholders and customers, unquote. So in other words, technical barriers are associated to the existing market environment. The market environment is shaped by competitors, customers, societal expectations, and policy, for example. And it is beneficial to develop this market knowledge or this knowledge about market. How is the market environment, or how is it shaped, already during our R&D activities, to be able to develop strategies of how to bridge the so-called valley of death, the gap between lab, so our work here, and then the market. This gap might have evolved because R&D activities prior to market introduction strongly focused on technological development and other interdisciplinary aspects that shape innovation diffusion were underrepresented. So bridging this gap is not yet market success. You see the market share is very low here. We need further effort to reach considerable market shares, market maturity here under a big area under the curve here. So to gain insights on the biorefinery valley of death, we conducted a case study focusing on lignocellulosic, green biorefineries and algal biorefineries. And we started off with an extensive literature review where we collected factors which hinder or incentivize commercialization. And we had the material narrowed down by experts from our Task42 network, and then developed a survey among research in the field of biorefinery. We applied an importance performance analysis and further assigned factors of commercialization to value chain stages and different dimensions. So here we have the value chain divided into stages and the dimensions. So this would be read like this. We have barriers, for example, for the feedstock supply, and those can be economic barriers or environmental barriers, for example. And then we conducted, as I indicated before, the importance performance analysis to set up our survey and analyze the results. The importance performance analysis was originally developed in the field of marketing to find out which attributes do customers like and how satisfied are they with that performance. So for the conducted study, a mismatch of importance and performance ratings signals that there are barriers. And this would be this section here where we have high importance, but low performance values. So we should spend our resources and make these factors better. For example, if we have low factor which is rated not important, but has high performance, we see this factor is already well developed, and we shouldn't spend more efforts on that. So here is an example of how we ask the questions in our survey. So for example, for the factor feedstock supply, the importance question would be, how important is the factor feedstock supply in your opinion for a broad commercialization of biorefineries? Please rate from 1 very unimportant to 5 very important. And the performance question then would be, how is the current performance of the feedstock supply for commercial scale biorefineries in your opinion? Please rate from 1 very high level to 5 very low level. And further, they were asked to explain the most relevant specific commercialization barriers in terms of policy, economic, society, and environment along the value chain. We contacted nearly 360 international experts in the field of biorefinery research, and 70 of which replied. So this is actually a very satisfying reply rate. And most of the participants assigned their main field of expertise to the lignocellulosic biorefinery, and we do have a bias towards Europe in our sample. So let's start with the lignocellulosic biorefineries. As it builds on pulping refinery, it can be characterized as most mature biorefinery concept in the scope of this investigation. And the analysis reveals the general tendency of high importance ratings with relatively lower performance. The perceived level of performance is, however, generally good. So the red line shows the mean ratings of performance, and the blue line here shows the mean rating for importance. And what we see here is that for economics and policy, resources should be invested to improve the performance. Low performance ratings of policy were linked to missing measures for economic support, but also missing measures for to increase bioproduct demand or feedstock supply. And as important societal and environmental dimension of policies, a need for more specific forest management regulations or ecologically driven tax systems was stated by the experts. And the low economic performance was linked to volatile feedstock prices, inefficient technology, and also low willingness to pay for bio-based products. So for the green biorefinery, the analysis reveals a similar mean performance and importance values. However, we see a tendency of lower performance ratings of policy and economic factors, which with at the same time higher importance. The economic issues of concern were linked to inefficient conversion processes and immature, complicated technology and no willingness to invest. That was one statement we had there. And the economic dimension to the bioproduct demand can be explained with reported low economic values of bioproducts from green biorefineries and cheap imported feed products like soybean feed at the same time. So the competition is really, really harsh. So especially considering feedstock supply, the survey reveals the demand for policies to improve support for sustainable feedstock and agriculture, and connects these issues also to a societal and environmental dimension. So we see that some factors actually are connected via another factor. And for the algal biorefineries, they can be characterized as newest biorefinery concept in the scope of our investigation. And we see higher mean performance ratings, but lower mean, higher mean importance ratings, but lower mean performance ratings compared to the previously discussed biorefinery concepts. This is actually plausible when we put on our technology glasses. So if we see that this is the youngest biorefinery concept, we can assume that more effort is being spent on technology development. And the availability of suitable technologies was reported as barrier. So here, the category policy was rated less important. We see it here for broad commercialization compared to the other factors. So maybe this is not yet rated as important. So this is actually quite interesting. Also here, the economic factors for commercialization show the biggest gap between perceived importance and performance. Sorry. And especially the high investment costs and cost for feedstock cultivation were stated as issues in the economic dimension here. So regarding societal and environmental issues, concerns about the sustainability of cultivation technologies were highlighted. Concluding, we see that for all biorefineries here, the importance of the economic factors for the commercialization does not match with the performance. So we find ourselves in this quadrant here. And the importance of policies is rated high, but performance to support broad commercialization is rated relatively low. We need to consider the different dimensions of the factors along the biorefinery value chain, and also the dependency of the factors was carved out in the study, and it needs to be highlighted, or the necessity needs to be highlighted to align different measures we set to support the market deployment. So those factors are interconnected, and we tend to work on single factors only and not on the whole system. Independent of the biorefinery concepts analyzed, we conclude that there is a need for policies to transform the market environment, which then levers the different economic aspects. The competitive advantage of conventional refineries, so oil refineries, is huge in light of the decades of promotion, the decades of they had time to increase the efficiency and scaling and market formation, etc. So that competitive advantage actually builds on market distortion because the environmental damage associated to this technology is not paid for by the polluter. And unless the market environment is not equalized by, for example, CO2 taxation or polluter pays principle, no matter which biorefinery concept will find itself really, really struggling with this market deployment barrier. And the good message is that we will keep on studying on this issue, and this study will go on also in the next triennium. So in case you would like to participate as biorefinery expert in our next survey, please contact me this time, not Johannes, but me. And in the meantime, please check out the results on the Task42 webpage and in the Global Biorefinery report, which will be published in spring, as we just heard. So thank you for your attention.
Thanks indeed to Franziska for giving us the details and insights to specific processes and valorization chains. I think maybe we should now recap our poll to see how our audience has been rating in this.
Is it possible to get it up again? Because it was
I hope so.
And then it disappeared.
Yeah.
So here
Yes,
it is.
now
Thanks.
we have it.
Yeah. Okay.
So what does it say?
Well, the most high scoring one is the one on economics being the biggest barrier, doubts of profitability, just as you said, in a way that you need policy to level the market playing field. That could be one interpretation. Then it's followed by which one is number 2, lack of incentives for biobased.
Yeah. So we also have the securing a reliable feedstock is also addressed quite important, as well as uncertainties in policies and in the legal framework, including CO2 taxation. Well, lack of public funding in development stages, and the incentives of lack of incentives for bio-based products is also at 38%. Well, we got quite a interesting coverage of all of them.
I'm actually wondering why the consumer acceptance of bio-based products is has such a low rating. because here I like to cite my colleague. She's doing research on consumer acceptance of bio-based products, and she says without acceptance, there will be no innovation.
Hopefully it's an indication that we see that there is acceptance, so that is not a barrier, because acceptance hopefully is already in place. And I assume that also, of course, acceptance is also quite strongly related sometimes to if you see that it is a benefit for you. Is it cheaper or is it more expensive? Or is it an equal choice for the bio-based options?
Well, usually when you're a developer, the main things you're looking at are basically the process, the performance, the technical performance of your process. You try to optimize that. In the same goal, you're looking at economics, and unfortunately, you forget the rest about it. And then when you're there, then you actually see that you're encountering a lot of other difficulties you haven't thought about it in the first place.
Yeah, it's a bit unfair with the technology readiness scale. We have all of the, actually it's focused clearly on technological development, and the last step then considers markets. So maybe it would be a good idea to take pieces of that last step and push it in front, and develop the markets along with the technology.
But I have one last question, Francesca, because talking about barriers, it seems quite, I would say, you usually get so sad when you talk about barriers because they are just hindrance, and we need actually to progress the biorefinery and the bio-based economy quite rapidly. Would you say that even though you focused on barriers and we had this question on barriers, do you still see that even though there are barriers, we could expect some kind of development the coming 10 years? Or so are you encouraged, or are you put down by the vast amount of barriers, or are they feasible to overcome, so to say?
Well, to be honest, I was a bit not so happy about it, the situation. But after I saw Bert's presentation just now, I thought, whoa, so many biorefineries are in operation. The question is how long? Yeah, because we know that the situation is quite fluctuating. But it still gave me a lot of actually encouragement, and I'm actually really motivated by all of those companies who really try to engage into this really competitive field. And I mean, I hope I got the message across that the market environment is actually unfavorable for biorefinery technologies. So that's why I think all of those who try this step towards the markets are really doing a good job, and keep it up.
That's a great encouragement. Thank you very much, Francesca. And I would say that we move on to the last.
Yes, but before we need to give a little Biorefinery
I forgot the gift.
Award to Francesca as well. While you have been talking about green biorefinery, so I thought, you know, some grass fibers as a byproduct from the green biorefinery process would be a nice gadget for you. I put them in the glass, so when you open the lid, you get a nice smell of the Alps whenever you want to take a short break or holiday. And as you are implemented or established in a competence center for wood and lignocellulosics, so they may do some work on how to utilize those fibers to use the properties or to make other products from, like fiberboards or such. And if you have some results, we would highly be interested to publish in our next coming report in the next triennium about green biorefineries. So this is your gadget to be sent away in the next days.
Thank you.
That's a perfect.
Yes, now we're moving on, Johanna.
Now we will move on for the last presenter of today. And we will be, what to say, waiting to see what he will get as a nice gift afterwards. But I'm very happy to introduce Dr. Marzouk Ben Ali. And Marzouk is a senior research scientist and also the manager of Biorefinery R&D program at Natural Resource Canada. And if we look at the title, because this is a quite long but also quite interesting title, to plan for the Canadian bioeconomy, we have gotten the European context a bit so far, and now we're looking into Canada and look into the circular bioeconomy from a lot of different perspectives. And you have a really good CV for this, Mr. Benali, because you have written over 100 peer-reviewed papers in international journals about this subject. And we also look forward to your perspective because it's quite broad. It's when we look into industrial symbiosis and such, to span over different topics, as we saw from the first presentation, is quite important. And you are skilled in not only technology, but also LCA and policy. So with that introduction, I give you the floor, and your presentation is looking good already.
Thank you.
Maybe a small amendment from my side. We already would like to recognize Paul Stewart as being a co-author of this presentation, holding a full professorship of chemical engineering at the Polytechnic in Montreal, and being also a consultant exposed to finding new solutions and optimizations in the paper industry.
Yeah, thank you both for this kind introduction. Yes, indeed, this presentation was jointly prepared by Paul Stewart and myself. And if I may just start to say special thanks to Bert, who did invite us to be part of this panel. Thank you very much for this kind invitation. So the outline of our presentation, we are going to walk you through some highlights on the Canadian bioeconomy. Afterwards, introducing, as Bert referred to, the IETS Task 11 on the industry-based biorefineries towards sustainability, as the system analysis and decision support system are the key drivers of this task. We are going to bring the importance of decision support system in the bioeconomy context and make an announcement on the upcoming workshop on the circular bioeconomy and biomass-based industrial symbiosis, and with some concluding remarks. Let's start with some highlights on the Canada's bioproduct sector by numbers. The overall, we have about 208, 210 private companies involved in the bioproducts. And this number, by the way, is really increasingly evolving in the context of the green chemistry, as well as the lignocellulosic product. Overall, this bioproduct sector is generating about $1.3 billion. On the bio resources that are involved in the bioeconomy market in Canada, we can say we have forestry, agriculture, and marine feedstocks. And in some cases, in some, I should say, locations, these three bioresources are also either combined or separately used with the municipal organic waste. If you look at this figure here, it's value chain pyramid, illustrating the increase here of bioproduct, the biomass input here, the profitability in terms of dollars per over dry ton used to produce such bioproducts. For example, here on the top of this value chain here, we have the bioproducts, including biomaterials and biochemicals. Clearly, these bioproducts are really economically viable and profitable. But if you look at on the bottom of this value chain here, we have biofuel and bioenergy. Due to the complex pathways that are involved, due also of lack of harmonized regulations, I should say, there is a little bit lack of the viability of such large-scale projects. So I think this gives you an idea where the upcoming priorities, in fact, in Canada, is a combination of the this bioproduct as well as biofuels. On top of that, of course, we have to mention the common commodities from the bioeconomy. And now I'm going to focus on the forest bioeconomy in Canada. In 2018, that I should say for the first time that the forest ministers of provinces and territories and the federal government agreed to establish a common forest bioeconomy framework in which policy measures are defined. And this framework is driven by 4 pillars here, as you can see in the slide. In this framework, the communities are at the center of really the Canada's forest bioeconomy. The importance of the community is due to the fact that there is a need of balancing the goals of the forest companies and the needs of the communities, including creating green jobs and generating income. All this to increase participation of the municipalities. I saw one question earlier on the role of municipalities. Yes, indeed, municipalities and the local communities are increasingly playing an important role in the bioeconomy. And also this pillar is of great importance because it involves the engagement of the First Nations in the forest bioeconomy. And we have another pillar here where there is a need to ensure this secured access to the feedstock, meaning the forest resources, to develop advanced bioproducts. And the third pillar here is related to the importance of making sustained demand for the first bioproducts and services. Just a few minutes ago, we said that there is still a lack of acceptance of the bio-based products. With such policy measures, the role is really to increase the acceptability of the bioproduct in the different industries. And of course, the fourth pillar is on the support for innovation. The good thing here, or the important thing to mention also, is the fact that biorefineries are part of the solutions to reduce the GHG emissions through the production of all the different bio-based products such as renewable fuels, biomaterials, and so on. And to keep giving you some indications on the growth opportunity of the bioeconomy, at the global level, there is a great opportunity by 2030 to generate a business of about $7.7 trillion US. And all this global opportunity is spread across different industries. This figure illustrates here the first row here, indicating the global market in billion US dollars, the lower, the mean and the max for each, I should say, industrial sector here. And the second row here is the Canadian share of these global markets. As you can see, the most markets that have been flagged here are the bioenergy, biofuels, packaging, of course, building, construction materials. More and more, there is an increased need of and implementation also of the green materials or biomaterials within the construction sector, as well as in textile and chemicals. Over here, for the Canadian share, depending on the industrial sector, it varies between 2% to 5%. So a clear indication here that the bioeconomy is growing, and I think it opens great opportunities even for developing new business models to support such growth. On the policy side, of course, when talking about the Canadian bioeconomy and more specifically on the Canadian forest bioeconomy, we have made implemented some policy measures. I think it's difficult to support such growth without establishing some policies. Among them, I'd like to highlight the new Canadian standards that have been already released to support the lignin bioeconomy as well as the cellulose bioeconomy. This is very important to mention because the goal of this new Canadian standards is really to help the lignocellulosic product reaching high level of market. And the second is the clean fuel regulation being implemented in Canada with the goal of gradually reducing the carbon intensity of liquid fuels. The goal is to reach about by 2030, about 30% reduction of the carbon intensity. And on top of this target, what we are looking for is what could be the incremental cost for the forest sector on the supply part and the transformation of the forestry feedstock when such regulations are implemented. And of course, other initiatives are already ongoing. This next figure slide is showing some scenarios related to policies again here. And if you look at to this first figure here, when you look at to this number in 2021, only 6.1% of the materials are recycled. That means circularity rate is very low in the Canadian circular economy. And if we keep the business as usual within next 20 years, as you can see here, it's not really an interesting scenario at all. So the other scenarios are really based on the European 27 vision, without net zero targets, and also another scenario, the same European 27 vision, including the net zero target. As you can see here, this the blue one here, without net zero target, we are going to increase the recycling, the circularity rate from 6.1% to about 50%, which is very great. And of course, if you look at the scenario, including the net zero, we can reach a level of about 25%. The goal of all these scenarios is really to significantly reduce the GHG emissions through such policies. And on the next slide, I would like just to share with you some Canadian forest bioeconomy large-scale projects. Of course, this is just a snapshot of more than 40 projects already implemented in the industry. The first one is related to the green industry, making green energy from waste. The Alberta Pacific Forest Industries here created a great opportunity by implementing a first in-kind plant to recover and purify biomethanol from waste, of course. This is a 10 million project. This, of course, created an opportunity to diversify the revenues of this mill. The second on valorizing the cellulose. So the Kruger Biomaterials has built the first commercial facilities to produce about up to 5 tons per day of cellulose filaments here that are typically used as reinforcement materials in, for example, thermoplastic, concrete, and so on. And the last example that I'd like to share with you is the lignin recovery plant to promote lignin bioeconomy. West Fraser mill in the west of Canada implemented a lignin recovery process based on the LignoForce system, which is one of the commercial lignin recovery and purification that exists already across the world. And the target is to produce about 10,000 of dry pure lignin. This is a 22 million project. And on the GHG emissions and net zero target, what I want to give you just a snapshot of the 2019 GHG emissions in Canada. Here it's about 730 megatons. If you look at the breakdown, this is very important to mention. Mainly the oil industry 27%, transportation 25%, and heavy industry 11%. I'm not neglecting the other contributions here, but if you look at this just three sectors and bringing the biorefineries and related technologies, for example, the transportation, one of the industry which is very hard to decarbonize is the aviation industry. So developing and deploying advanced technologies to produce sustainable aviation fuel is one way to decrease the contribution of the transportation sector in the overall GHG emission picture. And for the oil and gas industry, as well as heavy industry, the carbon capture and utilization, as well as sequestration, combined with hydrogen utilization, are part of the solutions to decrease and decarbonize these sectors. Or this, to mention that the Canada already established a clear vision to achieve the net zero emission by 2050 with, of course, 5-year emission reduction targets. That means every 5 years, there will be a review of what was achieved and how to accelerate such transition towards net zero emissions. And what are the key advantages and challenges for the Canada's bioeconomy? I thought that it's very important maybe to share with you one or two advantages and the key challenge that we are facing. One of the key advantages is the fact that Canada contains the most biomass per capita in the world, which is a great asset when talking about, for example, the growth of the forestry bioeconomy. And just to give you an idea of this, they represent 65% of the world theoretical bioenergy potential. The second is to mention that Canada is the second largest exporter of forest product in the world and has mature and efficient wood fiber collection system. This is a key asset of the forestry industry. Of course, we are facing some challenges, and one of the key challenges in Canada is the fact that natural resources are under provincial jurisdictions, meaning that there is a lack of harmonized policies across Canada. And this also, with this, we are facing another kind of challenge, is some difficulties to replicate circular bioeconomy business model from one province to another, because mainly the bioeconomy projects and the related industrial symbiosis systems are designed for a specific location. For example, in one province, you will find within the industrial symbiosis a strong component related to the chemical industry. In another province, it's much more the oil and the gas industry that will be combined with biorefineries. So it's always difficult to replicate the same business model from one province to another. But these challenges are opening also opportunities to work together to create partnerships across the key stakeholders of the bioeconomy in Canada. And this, the second part of this presentation is related to the IETS Task 11 on the industry-based biorefineries towards sustainability. The key objectives are really to develop the industrial solution that could serve as platforms for deep decarbonization of different industrial sectors through the sustainable integration of biorefineries. I think it's very important. The key word here is the integration as well as sustainable manner. And the other objective of this task is to promote the system analysis. In the context of the industry symbiosis, the system analysis is very, very important. And also, as we have mentioned earlier, I was glad to hear that in the poll, the uncertainties in policy, risk in market, have been highlighted, which means that flexible decision support systems are needed to accelerate deployment of the bioeconomy. And this task is biomass agnostic, meaning we're including all the bioresources. And so far we have Canada, Portugal, Sweden, and Austria involved in the task 11. And we are working hard, Paul and I are working hard to bring France, Spain, United States, and the Netherlands in the arena of this task. And we have mainly 4 key subtasks. The first one on decision support and ex-ante research, which is already initiated subtask. And we are under development of 3 new subtasks. The one is really technology pathway is towards negative net zero emission biorefineries. All this will open really a great opportunities to collaborate with, for example, Task42, as Bert mentioned it earlier, and also with other IETS tasks. And on the decision support system, I just was referring a few seconds ago on the importance of this, having flexible decision supports to help deployment of bioeconomy. What are the key drivers and challenges for decision making in the bioeconomy? Clearly, this will help identifying successful biofriendly strategies because we're dealing, as was mentioned in the poll, with the different level of uncertainties as well as market risks. So the uncertainties can be related to the technologies, to the emergent technologies, which are not yet demonstrated at large scale in different domains. And also the market adoption of the bio-based products. I think here clearly there is a need of working on multi-sectorial. I think we have seen that the difficulties of the acceptance of bio-based products. Clearly here what we need to do is to evaluate the opportunities to build bridges and create balances between for example, the forestry sector, the agriculture sector, with the recipients of the bioproducts, such as chemical industry, pharmaceutical industry, and so on. I think it's very, very important. The other aspect to mention here are the critical decision to be made at early stage of designing, for example, biorefineries, where the uncertainties are still high. And so far, no initiative can be completely de-risk the markets or de-risk the technology. So this is why there is a need of flexible decision support tools that can assist mitigating all these kind of risks. And in the context of biofriendly decision supports are dealing with looking to different impacts, the technical, economic, environmental, social, policy, and legal aspect, as well as supply chain. Only the bioeconomy, only in bioeconomy we can deal with these different aspects, and we have to build a decision support system in which we will capture the most advanced knowledge on the bioeconomy, on biorefineries, as well as the data, meaning the feedstock, the data feedstock, the data on the already deployed biorefineries, and so on, as well as different technology models and different tools to look at to the different scenarios involving all these metrics. And the users of such tool will need, of course, to have a flexible visualization of the key outputs to help the stakeholders making the right and informative decisions. On that, I will just to introduce at high level one of the tools that being developed by the Task 11 is the iBioref, which is developed by Bioenergy of Natural Resources Canada. It's simply a project modeling and evaluation tool in which we included different database from feedstock to the core advanced biorefining technologies, along with local specific project assessment. Earlier, Bert was referring to the locations of different biorefineries, and within this tool, we have different countries where either biorefineries are already implemented or being implemented or potentially be implemented. We have defined these countries, and we have already some key examples implemented in this tool. And we have more than 50 multidisciplinary decision metrics covering the techno-economies, the LCA performance, environmental performance, social, and also policy metrics. So this is a multidisciplinary approach that will help mitigating risk, as I said earlier. So, and I will end with this announcement on the workshop that we are preparing. This workshop, the objective of this workshop will be really to look to the, as I said, to the industrial biomass, industrial symbiosis systems that will support the deployment of the circular bioeconomy. The objective is really, to review the emerging trends and challenges, of course, and also develop a harmonized circularity metrics. I think this is of great importance to work all together to have this harmonized circularity metrics. The targeted date is the second week of February 2022. We'll keep you posted, of course, through the Task42 11. So to conclude, the key takeaway messages is clearly what I want to say here, that the Canadian biomass is an economic development engine. It's very important to mention this. And it represents about 31 billion of economic benefits. And biomass is currently the #2 producer of renewable energy in Canada, which is accounting for about 28% of all renewable energy in Canada. And the bioeconomy is a great opportunity, but it will need really flexible decision support to enable the assessment of scale-up risks and opportunities for biorefining. The second part of the takeaway message is related to what I have highlighted earlier on the circularity rate. There is a clear need for Canada to improve the circularity rate, to bring it within next 20 years from 6.1 to at least within the range of 15 to 20%. And the industrial symbiosis and climate and other policies are the key strategies to be highlighted to support the deployment of the circular economy. And the Task 11 is really dealing with all this aspect and will be executing some key specific activities within the next 3 years. With that, I'd like to thank you on behalf of Paul, on behalf also of Task 11. I would like to thank you for your attention. Again, thank you for this invitation.
Thank you very much. We have a question, and I do not think that it was primarily directed to you, but I think it fits anyway, since you were the last speaker. And we have been talking now about Canada, that has great biomass resources, and we have also been talking a bit in the first presentation in a bit of a Nordic perspective. Yeah. But we got at least two questions that tangles up on other parts of the world. And it goes in a bit about, if we look into, because we need the whole world to be a circular bioeconomy. And
sure.
Could you comment on how could these decision support tools be used also for implementing circular bioeconomy in development countries? And are there examples from like other parts of the world that we could also highlight?
Yeah,
how could one engage from these other places in the world?
This is great. This is really a great question, and it is really related to the mandate of the Task 11. In fact, we are working with Scandinavians, in fact, out of the Task 11 since few years, and one of the target for us was really by learning from Scandinavian and other European countries as lessons of the industrial symbiosis system that are already implemented and the biorefineries, is how to deal with different feedstock. And with Scandinavians, Canada and Scandinavian countries, we have relatively similar approaches, since the forestry sector is playing an important role in the circular bioeconomy. But the key point is how to leverage on some key experiences and also the business models. I think the key challenge here, what could be the best business model to I should say, to expand the deployment of this industrial symbiosis system, where the biomass is playing the central role, because in all this symbiosis system, what we are thinking is the core pathways will be related or built around biorefineries, but also bringing different industrial sectors such as chemical industry and or oil and gas industries. But clearly, the first key message at high level is building on the lessons learned and the established already business model. This will help really the optimal deployment of the industrial symbiosis system and the circular bioeconomy across the world. This is what I can say on that. And the decision support system, having different biorefinery pathways and having access to the local supply chain models. This will help building different really strategies, how to bring different this different business model, as well as different strategies within the downstream part of such systems. Meaning, are we going to focus on the renewable fuel? Yes or not? Are we going to combine renewable fuels and other co-products and so on? But clearly, the key messages that we're hearing is the most sustainable strategy should be based on combining a product portfolio where renewable fuel can be combined with other bioproducts to create this growth that we are expecting.
Masouk, I would like to address another question, because you've been announcing that workshop in February, 14th of February next year. Yeah. What do you envisage? What participant you would like to have on that workshop? Is it industry? Is it from the private sector? Is it R&D? Is it an open workshop? Could you please tell us a little bit more?
Thank you very much for this. In fact, one of our targets, since we are dealing with the industrial symbiosis system, is to bring more and more industry stakeholders. This is one of the targets. Of course, in the meantime, we'd like to bring also the research organizations working on different models of circular bioeconomy. This is our primary target for this workshop, Michael.
Okay. Well, maybe let's close the specific questions for your speech. And of course, I would also like to give a little gadget to you, Masouk. And what I've thought about is this: it's maize, but it's not that part, what you could eat or feed or turn into starch or sugar, whatever. I was thinking about this part in the center. So let's say the spindle of it, the maize spindle. It's an interesting feedstock, I think. You can make some products out of it. For instance, there is a small industry, it's grinding them, and they apply the solids, the granulars for in an air jet, like sandblastering, and you can degrease oily surfaces in the metal industry. It works very well. That's, for instance, one application. I don't know how to send it over, but I will find a way to do that. Okay, thank you.
Thank you, very interesting. Thank you very much.
Well, I would like to open the panel now for all our speakers. So I would like you to switch on your cameras so that we can come conjointly on the screen. And revising or revisiting some of those questions, one I would like to address, and I think to all of you, is while keeping in mind all the possibilities on technologies, how to decide the best use for a specific feedstock. Who would like to give some comment on that?
I can start, Michael.
Yeah.
I can start based on what I have said a few minutes ago. I think it's difficult to say straightforward. This is this what we should target. Clearly, from a country to another, and from a feedstock to another, there are some key specific considerations that we should have. The first is, if it is in the circular bioeconomy context, clearly we are dealing with a variety of feedstock. And I think the co-production of renewable fuels with some co-products such as lignocellulosic based co-products could be something to be considered. Because clearly, as I have shown earlier, if we are targeting only the renewable fuel, it will be really still a challenge to make such application economically viable without financial incentives and without also very stronger regulations that we're having now. Paul?
I'll add to it also that you know, the parameters that are specific to every single biorefinery, from the biomass type that the question was about and the cost, through to the gamut of technologies and best in class, through to the policy background, very specific. But the question was about the best one, which means you also have to evaluate using other biomass sources in other locations, because the best one is the most competitive one in the long term, I guess. And so the tool that Marzouk introduced and others really can be powerful, and that is the focus of Task 11, is how to use tools to evaluate questions exactly like that.
I would like to come back to one key message Marzouk brought to the table, basically saying, okay, it's very difficult to replicate while successful biorefinery models from one region to another. But does this consequently mean that we need to first evaluate or assess a region to see how to best embed technology?
Yeah, I think absolutely. In fact, what we should assess the first is the needs of specific regions, because what we are looking for is to create regional circular bioeconomy. We have to look at the already established industries in a given region. This is one thing. And we have to look at also the kind of the feedstock that are available in this region. And also the opportunities of blending different sources of feedstock. These all questions, we should answer them at early stage before even designing a kind of industrial symbiosis system. I think clearly in the Canadian context, this is really very important to be considered.
I assume that you might want to comment on that as well, Mats.
You are muted. Yeah. No.
Yeah.
Okay.
Well, what I was starting to think about here was that I'm like hearing some kind of idea about a planning economy. While I would say, what about the market then? And what about the market economy? Wouldn't that sort of, what we found was that we found a lot of inherent driving force within companies that would started with biofuels that through their business development were sort of either through partnerships or what they were doing themselves were sort of developing into biorefineries. And I think that wouldn't require a lot of planning. And a lot of tools. That would rather, I don't know, it's more the institutional conditions, I guess, that will open for that kind of development. And of course, knowledge that could inform actors would always be useful, but I think it's very difficult to plan such a development.
One add-on question for you, Matt, because at your presentation, there was one question, okay, what is the role of the municipalities or the state to support this sort of setups? Do you think they have a key role in getting something initiated?
Yeah, I think in our case in the Nordics, I think, for instance, they have been instrumental in the development of joint energy systems, where the biorefineries become maybe a part of the energy system of a city with district heating, etc., and where different waste and other stuff from the city becomes fuel for some of the processes. So we see, of course, many examples. So we are, I mean, originally industrial symbiosis, what used to be what we call it, now we always almost say industrial and urban symbiosis, because there is always also the connection between the industry and its cities or regions where they are connected as well.
Perfect. And Michael, do we have time for I think we have time for at least maybe one or two more questions.
Yes, we do. We take our time for sure.
Yes, because I also wanted to ask, since we were looking into those databases that Bert showed, when we see this, all of these biorefineries, we kind of indicate some kind of development. Would you say that, given those data that we have in the database, would you be so brave, given that in Europe it's late night now, Bert, to say that you could see some kind of trend? What do you, based on this data that we have, foresee for the coming 10 years? What do you think that the database will contain in 10 years?
Well, this hasn't been analyzed in detail yet, but what I do see is, I said, we already started many years ago as Task 2007. And at that point, we really said, okay, we can distinguish between two types of biorefineries, the energy-driven biorefineries and the more product, say, material chemical-driven ones. And although what I showed in the slides is that there are still a lot of energy-driven biorefineries, I do see that more product-driven biorefineries now arise. I didn't show any results in my slides on TRL level and things like that. So they're sometimes at the lower TRL level, not commercial yet, etc. But that is, I would say, a trend. So after the first initial hurdle of establishing biorefineries at all, now companies are thinking about more high-valued products. That would be a trend that I would recognize. And okay, we have to analyze it in more detail. And indeed, Franziska said, hopefully they will remain a biorefinery, because we also saw a lot of initiatives that were stopped again. But okay, and that's actually also one of the purposes of this database, so that we can monitor this a bit during our next triennium and and hopefully after that as well. Does that answer your question for now?
Yes.
Perhaps others can see different trends. I don't know.
No, but I guess that's a way, if one wants to connect it to industrial symbiosis, we can say that also, if we look into the concepts that Mats showed, that usually you start with some kind of focus in your production. You start with a product that you have some kind of business model for, and that's the rationale behind your investment. And then when you have the possibility, when you have stuff up and running, you kind of looking to and see what other opportunities are there when I have this production, and you kind of add on. And that would also be, in a way, what you say, that you see they will see more high value products, because usually when you have those smaller flows with higher values, that might not be the rationale be like at the basis of a large investment, but when you have the investment, that is usually a good add-on. So you can see the symbiosis kind of, or the possibilities of the biorefinery gradually growing, maybe.
Yeah. And I must say, I agree with Mats that I think certainly, at least in Europe, we do not approach it like, say, a grand design, a blueprint. You have to do it like this. So the word, this is the best approach, I'm always already a bit doubtful there. It really depends on the situation. Although, for example, we now have China as a new member in IEA, and I could imagine that they perhaps approach it a bit more in a grand design approach. So it might be nice to see what happens there in the next years and to compare the different approaches.
I would like to have a last question, and specifically addressing it to our Canadian participants. You have been well, talking about this decision support system. So, well, if I represent an industry and would like to get your advice or your service, how could that sort of cooperation work? Maybe you can put that into a nutshell.
Okay, I thought, Paul, that you will jump in. I will jump in here. So clearly, it's an easy process. It's really the way to do it is just to send an email to us, and we can develop some biorefinery scenarios. This is one approach. And the second, we can share a version of our tool open, for example, for 1 year utilization, and organizing a webinar to guide the user from the industry. It can be an engineer or non-engineer, because the design of this tool was done to be used by an expert and a non-expert. It's a stepwise way to develop a biorefinery project through such decision support tool. So either contact us to do some scenarios, meaning that the industry, stakeholders should share a minimum input data with us under an NDA or on a gentleman agreement. Usually we are never disclosing the names of the data providers in the such decision support tool. And the second, as I said, really sharing a version. The version can be used not only with the industry bioeconomy stakeholders, even with the academia. This is for sure.
And a complementary comment to that is join the subtask on DSS ex ante, which is really about the plurality of perspectives, which, you know, we hope that IBRF is a foundation, if you will, to incorporate all these different perspectives in there. But it's not on crowd and dried answer, and task 11 on DSS ex ante is about how do we suss out, you know, some of the best answers, and as you say, Bert, quote best answers for our company.
Well, that doesn't sound too complicated to me, actually. So before we are starting our closing ceremony, I would like to make an announcement. So if you please look into the chat, you will find there a link. It's a link of Wonder.me. Wonder.me. That is a platform where we can keep on our discussion after that session. So we can log on and continue. So let's call it a chill out phase on that. I would highly invite you to come along. Special invitation to our speakers, because there might be additional questions for you all. Well, and I want to thank you all for being here, giving your presentation. And Johanna?
Yes, I would like to say thank you as well. It's been great to listen to you all, and I hope that you can answer additional questions in the, what to say, chill out lounge.
Okay.
Thank you. Thank you.
And of course, to our audience, thank you for participating. Well, nice that you have been along. Stay healthy, keep the good spirit, and hope to see you soon in person. Thanks indeed.
Thank you very much.